Hello and welcome to Book Analysis and Visualization with Python and Jupyter Notebook. So this was a webinar that I ran last night, and what you're watching here is basically the full recording, just edited and streamlined a little bit. But I thought I would give you guys a little bit of a quick intro before we get into the webinar. So what is it all about? Well, think about this. You get Python to read an entire book, and rather than have data being printed out, you visualize it. And we do this with libraries like Pandas and Matplotlib. And what you get is these charts, which, for example, show you who the heroes or who the protagonists of the book are, whether they're heroes or villains, what the emotional arcs are for the book as a whole or for any individual character. And there's many, many more types of analysis that we're going to go through. Now, worth saying, and the links are going to be below, this work is based on a course that's published on the Digital Technologies Hub, which is an Australian website funded by the Australian government for teachers and students to basically get free resources in digital technologies. So this is a project that I did with them in January. And what I did here is basically expanded on that 10-part project with these graphs and visualizations, making that data and the results of that analysis kind of more, I don't know, interactive and visible and interesting. So the general theme is going to be natural language processing. Now, you might have heard this term, but if you haven't, natural language processing is the application of computational techniques to the analysis and synthesis of natural language and speech. So in this webinar, we focus mostly on the analysis and sort of visualization of that analysis. The synthesis of speech is more difficult. So the domain of natural language processing includes both natural language understanding and natural language generation. The generation is currently a subject of a lot of research in the domain of artificial intelligence. Now, this is a useful graph to look at because natural language processing really overlaps with three fields. So the general computer science and data structures, linguistics and the human language. And obviously, to understand language and break it down for a computer, you need to understand things like grammar and syntax. And again, artificial intelligence, which is involved in many ways, particularly when it comes to natural language generation. However, the components of natural language processing, given that it's sort of an advanced field, are actually fairly easy to understand. So we're going to do things like removing punctuation, basically removing weird symbols from text. We're going to tokenize text into chunks that are easier to process, like words, sentences, paragraphs, and chapters. We're going to use things like stop words to get rid of words that have no meaning and then analyze the remaining text to find meaning. We're going to do frequency distributions, which are essentially dictionaries that have a word and how many times it repeats. We'll look at sentiment analysis, which is the study of emotion within text, basically positive versus negative emotion. That's polarity, and bias, which is subjectivity, as well as part of speech tagging, which is the categorization of words into, adverbs, adjectives, nouns, pronouns. Okay, so much for the introduction. I'm going to let you into the live webinar recording right now. And before you do that, do remember to like and subscribe. See ya. Okay, we're good to go. So, let's start by looking at removing punctuation. So we're going to do this by writing a simple algorithm. We create a string with all of the weird symbols that are in each book. We're going to replace it with a blank, and we are going to return with a function the full string without punctuation. So this is going to be something that we do to the book, and then we use the process text. There's the example. So you will remove the commas and the exclamation mark. There's a special exception that you have to make for full stops because you want to also segment the book into sentences. After removing the punctuation, we're going to do a bit of tokenization, breaking the text into words, sentences, paragraphs, and chapters. So depending on what you're looking at, if you want to find out what the book is about, you'll rank the words in a frequency dictionary. But if you want to see how it flows, you may want to analyze the book in sentences or paragraphs or even chapters. After that, we're going to look at stop words. This is going to be a very simple NLTK function. So we're going to access the special variable that contains a number of words in the English language that don't convey too much meaning. We're going to eliminate them. It is also possible to go to GitHub and just download top 100,000, 2,000, 10,000 most popular English words and eliminate them from your text for analysis and see what effects that has. Next up, frequency distributions like FrecDist. Here's the sort of graphs that we're going to generate. I'm going to do this in a bar graph, but the whole idea is you find out what the book is about. So you can rank all the words, you can rank verbs, you can rank proper nouns, and that really reveals both topics that the book is about as well as sort of protagonists and characters. Sentiment analysis, there's two elements. We're going to focus mostly on polarity, and that is how emotionally positive or negative a text is. And we are going to do this to find out whether a protagonist is, say, a hero or a villain. And we're going to find out the emotional flow of how events take place in a book and sort of plot that with a line chart. There's also subjectivity, which we're going to look at, but not in great detail, and that is how subjective versus objective the text is. It's not really that interesting to do that for a book like Harry Potter, which is fiction. It's meant to be descriptive, but basically objective text is something you would find if you opened up a manual. So if I open up a manual of how to use my, I don't know, mixing board or microphone, that would be very, very low in subjectivity. But if I opened a fiction book or a poem, that would be very high. Basically, with this sentiment analysis, we can analyze how emotional and how descriptive a text is. POS tagging, this is an NLTK function, and that is basically using Python and NLTK library to categorize text. So for every sentence, it's going to label every single word. So for example, and now for something completely different, and is coordinating conjunction, RB is adverb, in, so that one is preposition. Frankly, this includes so much grammar and technical terms that I'm not familiar with half of them, but we're going to use it for verbs, and ranking all the verbs in a book is actually quite interesting and insightful. Okay, so here are some modules that we're going to use, some Python tools. First is TextBlob. And on my resource page, I've created a little bit of a playlist with TextBlob. TextBlob is a module I like because it takes different modules and tools from NLTK and Pattern that are really easy to use. So it's basically a library made up out of other libraries. And I've used it a lot because it works with REPL, so you can use it in the cloud. But we're going to use TextBlob for sentiment analysis, polarity, and subjectivity. I suppose it's quite interesting to study a little bit about how TextBlob calculates sentiment. I'll tell you this in really, really brief. So there's an institute in Belgium called CLIPS, Computational Linguistics and Psycholinguistics. And they basically contributed this fantastic Python library, which reads text and tells you what the emotion is. How it works is really simple. So all of the adjectives and emotive nouns are tagged. So they have a value. So if I say happy, it has a value of sentiment. It'll probably be like 0.7. Maximum is 1. Minimum is sort of negative 1. But how do they assign these values? So some of these values have been manually assigned, but others have been assigned by reading millions of Yelp reviews. And Yelp is your American place where you leave restaurant reviews. So they've been coordinating adjectives and stars in a restaurant review. And so the pattern, which is the pattern sentiment analysis library, is over 80% accurate when predicting stars in restaurant reviews. That's what it specializes in. But for other applications, its accuracy is about 75%. So here are some examples of how it works. So if you say the word happy, that's 0.8. If you say I'm happy today, it doesn't matter. It only recognizes one tagged adjective. But if you actually use words that sort of amplify, like very happy or not happy, that would affect the polarity score. Yeah, not happy would make it negative. But if you actually have text that does not have any emotion in it, you're going to get a polarity score of 0. So next up, we're going to look at the NLTK library, which is basically the #1 place where you do natural language processing for Python. So NLTK considers itself a platform. It's open source, and it is a tool for using with language data. And it's primarily used for tokenizing and tagging text. So that means chopping it up into relevant bits and tagging it as what part of speech it is. But NLTK has also got some other tools that are used for visualizing. So for visualizing, we're going to use a different library. We're going to use Pandas and Matplotlib. So Panda it's a data manipulation tool, and it's built on structures called data frames. And these data frames can then be plotted using Matplotlib into various graphs. So essentially, this is, I think, the easiest way to take text-based data and to take dictionaries and represent them in nice visual ways. I have only used these two libraries for maybe 10 to 20 hours, and I found it relatively easy to draw graphs. So hopefully I'll be able to help you guys out with creating them as well. Okay, time to look at some code. We're also going to use this tool called Jupyter Notebook. I will put in the resource, and it's going to be in your email as well, instructions on how to install and use Jupyter Notebook. But Jupyter Notebook is basically standard Python that executes a little bit differently. So if you were to write a normal Python program, you would have files, and files would reference other files. Jupyter Notebook more or less just is a program that you can execute a little bit like a REPL. So you could basically take a chunk of code, run it, print it, take another chunk, run it, print it, and look at your program in those chunks. So this very first collection of chunks of code, we call that a notebook, is going to tokenize our text. So I'm going to use a mixture of NLTK built-in functions, and I'm going to do some stuff manually. So this text here basically opens the Harry Potter book, which is here. It's a text file. You can get it from GitHub. You can get it from Project Gutenberg as well, and it prints it. So this very first cell, we've printed out the entire Harry Potter 1 book. So in this next cell, we have defined a number of functions. The very first removes punctuation, so that's sort of the punctuation. You have an ability to have an exception, meaning a character you don't remove. We're going to need to do that with a full stop to break it into sentences. But basically, you put in a string, you return a string without punctuation. The next set of them is very, very straightforward. So you have a word list, you put in a string, you return a list of words. So the very next one is you return a list of sentences. After that, you return a list of paragraphs. And then chapters. So paragraphs are split. You split it by the double new line character. Basically, when there's a double new line character, there's a new paragraph. So you can split it that way. And the chapter is you split it on the word chapter. So if your book, let's see, where's my Harry Potter? If the book didn't include the word chapter, then I would have manually added it. But this book included the word chapter. So those are the functions. I'll run that. The functions don't do anything. I basically run the functions and I create this list of words, sentences, paragraphs, and chapters, and then I save them as JSON files. So what's going on right here is that I have that saved list of sentences. Now this saves me a bunch of processing time. I don't necessarily have to do that. I could have just used this and just used the variable in future programs. But I figured that this whole thing is going to run faster if I'm not generating them every time I use them. I generate them once and I save them in memory. So I'm just going to run some tests here. And this is the list of words, right? So we just print the first 20 in the list of words. And if you were to go and look at Harry Potter, see Harry Potter and it would be Harry Potter and the Sorcerer's Stone. So like that basically breaks the book into individual words. Here, we're going to see how well the breaking it into sentences. So this is how, so now it's printing the sentence list. Actually, I probably could have, I print a sentence and a new line. And I could have printed something like a separator, like that, just to tell me where a sentence begins and ends. So that's a sentence. What I really like about it is this is why I used the sentence tokenize tool from NLTK, is because it doesn't break the Mr. Mr. would have been a whole sentence if I just split on a full stop. It actually keeps the 3 full stops, and then you got Mr. and Mrs. So I still kept the, so yeah, this was just so much better than I would have done it manually. What's next? Paragraphs. So paragraphs I've done manually, just on 2-line characters. And as you can see, these are the first 20 paragraphs. I guess that's a paragraph and that's a paragraph, anything with 2 spaces. But as you can see, for once it gets going, it really, really is accurate in terms of defining what a paragraph is. So those are the, those are the programs. And the chapters. Again, the chapters is a little bit funky because chapter 1, because it splits on the word chapter. So the first chapter is technically that. We're going to get around that in the text. It's just a little artifact. As I said, it can be an art versus a science. Because if the book started with the words chapter 1, it would have worked perfectly. But I'm quite happy with that. And I sort of wanted to show you guys that, you know, you can design these functions perfectly, but you just need to double check how they work. So I printed the first 20 items in all of these lists, because if my functions did a bad job of breaking the book into, you know, words, sentences, paragraphs, and chapters, then I would get rubbish results. So we've checked the data, data's good, and these tokenization functions work pretty well. Okay, next up, ranking proper nouns. So the idea in this collection of little programs is this. We're gonna isolate different categories of words. And in the end, we're really most interested in proper nouns. And the reason for that, the reason why we're most interested in proper nouns is, well, they tell us who sort of the heroes, villains, and popular places are. So proper nouns are definitely things that are going to be unique to that book. So how do we go about ranking them? Well, first things first, we're going to import all of these various libraries from NLTK. And we're going to open the book. And we're going to import the words. So remember that we tokenize the words. We save them as a JSON file. Now we're going to import them. And now we're going to create something using NLTK called a frequency distribution. So this is a dictionary. I could have done this with about 4 lines of code, but I just used the NLTK tool. So that's a dictionary where, you have a word and how many times it repeats, a word and how many times it repeats. However, the data type of it is not a dictionary. It's some special NLTK object, but thankfully it's convertible to a dictionary. So I convert it to a dictionary and I print it out here. So now, okay, we have a word and how many times it repeats, but the order is random. So now I want to rank them. Okay, how do we do that? So you can use this sorted method, and that works on dictionaries. However, what it does is it puts out a list. So we have some Q&As. usually full of spelling mistakes. Is it easy at this point? Analyze. Is there a package? Banu, sorry for the interruption, guys. I will, very first slides. Okay, so Banu, I will send you the links at the end to the PowerPoint. It will be in the follow-up email. I'll just attach a link to the PowerPoint. And as for spelling mistakes, there are plenty of Python packages that automatically correct spelling. We can look them up at the end. I haven't really used any, but I have seen people use them, and that's a very standard application. Okay, we were at the part where we created this ranked list. So we use the sorted method, and now this dictionary is a list starting with the highest, most popular words. So Harry should be number 1, or maybe it's going to be something else. And now here we go. We just cycle through it and print it. So this doesn't really tell us that much about Harry Potter. I mean, if I gave this to Sophie and I said, does this represent Harry Potter? The, to, and, a, of, so Harry does make it somewhere. But as you can see, like there's all of these words that have no meaning. The, to, and, a, of, was, he, in, his, it, said, you. Like English language is mostly made up of words that connect other words and have no meaning. So, okay, we can rank them, but we need to do some filtering. So now we're going to use the NLTK set of stop words and get rid of them. And what do we have when we run that? Well, look, Harry's now first, but then there's said, Hagrid, back, one, got, didn't. Even this doesn't tell us all that much. And so after removing the stop words, we still need to do a little bit more filtering. So now we actually can print, we can actually take the proper nouns. We're going to use the tagger in NLTK to create a list of proper nouns, and then go through the ranked list and say if the word is in proper nouns and the word is title. I think this is completely redundant because proper nouns all have capitalized first letter, but fine, I just decided to double check. Then you print the ranking, and all of a sudden now you know what the book is about. There, you know who's in it: Harry, Ron, Hagrid, Hermione, Professor, Snape. There are some glitches because, like, what professor? There could be multiple professors, and that is something we're going to look at in the next one, because there's a way to analyze multi-word names. But for now, this is pretty good. Just for a demonstration, I've also created a list of verbs, and I've also filtered out words that are tagged as verbs, but are also tagged as something other than verbs. So meaning these are the top of the words, which are always verbs. And if you think about it, just add to be, to have, to back someone, to like, to know, to get, to see, to do, to think, to go. And I mean, that's what the book is about. I don't know how yeah got categorized as a verb, but face, to face. So yeah, that was it. I'm just going to rerun the cell one more time. And that is the list of verbs. They are somewhat interesting, but I have to admit, they don't really tell me all that much about the book. However, if the book had some weird, if the book was about fishing, you would have 2 fish right there at the top of the list. However, this is my favorite bit. And this is where we convert the dictionary to Pandas data frame. And we just do it for the first 30 items. And then with just this one line right here, we can plot the bar graph. That's the size, 20 by 10. That's actually inches. Again, I have a feeling my screen is less inches than that. But that's what the library says these are. That's the width and the height. And this is the title. So when we scroll down, you actually see we have Harry, Ron, Hagrid, Hermione, Professor, Snape, Dudley, Uncle, Malfoy. And then you got some stuff like well and oh. And we can like get rid of them. Shouldn't be too hard. So if you want to get rid of certain words, I mean, they're all in the ranked list. You could just say ranked list.remove, and then you can remove well. While we're at it, we can remove O. So I'm going to run this cell, and just to confirm, there's O, there is well. Clearly, J.K. Rowling has the character say, oh, well, a lot. So remember how we had a bit of an issue with the fact that you had like Professor and not Professor Dumbledore. So I Googled my way around this and found that people have been working on this problem, and I've basically just copied and pasted a function from Stack Overflow that claims to identify human names, and it does a pretty good job. So it goes through the entire Harry Potter book. It puts the text in, and it's going to it's basically going to put out, return a list of 2 or 3 word names. So it has a couple of categories, like that each word in that sequence of 2 or sequence of 3 is capitalized. And there you go. Albus Dumbledore, human name. First Class is a human name. Grand Source is a human name. Dinky Doodydooms. Pierre's Polkis. Boa Constrictor. So the accuracy, there are 2-word proper nouns, but not all of them are humans. However, if you were to rank them, all of these people, Sophie, you can tell me if where's the first mistake, but yeah, we got Uncle Vernon, Aunt Petunia, Hermione Granger, Privet Drive. There you go. That's not a human. That's the street. Professor Flitwick, Great Hole. Okay. As you can see, probably about 80% accuracy in identifying multi-word names. So yes, the biggest flaw in the previous algorithm was that it took single words, but this one takes multiple ones, and you can sort of get around that. So now we're going to get into TextBlob. I'm just going to go into these cells and clear all output. So that way, if I run them from the top, I won't forget. So the goal here is chapter by chapter, I'm going to get a sentiment graph. I want to know how the emotion changes chapter to chapter. And let's have a look. So we load in the book, and now we load in the chapters file. We create a dictionary where we're going to have the key in the dictionary. So it's going to have a chapter number and then all the text. And this is where I create that dictionary manually. So remember, I could have done the same thing for the frequency dictionary. It's really like a, 2-3 line job, but the NLTK did a better one. So, but now we've created it. And this dictionary contains a number and a chapter. And now if I run it, it will say chapter 0, because remember how we cut off that first bit. It was before chapter 1, but there you go. This is the sentiment level of chapter 1, chapter 2, chapter 3, 4. And now we can basically put that into a bar graph. And these are the chapters and the average sentiment. Sophie, do you remember if there's anything that happens in chapter 3? Because that's the unhappiest one in Harry Potter. If you're not sure, you can check back in and send me a message in the chat. But yeah. So yeah, we can just sort of tell that something goes wrong in chapter 3. And I'm surprised that chapter 1 isn't that negative, because he hates living with his uncle and Dudley, who kind of bullies him. So I could have also printed this as a line, but I just feel like a bar graph actually represents it better. All right. So next up, heroes and villains. All right. So this one is, this is a bit more complicated. Okay. All of those NLTK tools are imported. I'm going to actually open the book and have paragraphs, words, sentences. I'm not really going to use sentences actually. And I'm going to use this function that takes in, let me just clear the cells, all output clear. So this function takes in a person's name, a candidate, and a paragraph list. And then paragraph by paragraph, it basically checks if the person is in the paragraph, what is the emotion of the paragraph. So basically, if you're a character that every time you're in the paragraph, it's a negative paragraph emotionally, then you're going to be a villain. And if you're a character that it's always positive, you're going to be a hero. And again, the accuracy of this is pretty good. Maybe Sophie will critique it when we get to the actual results, but that is the, that's how it works. I've also added extra weight to very, very positive and very, very negative emotions. So I test this out. I put Harry as protagonist, and Harry gets a score of 89. We're going to see how that's relative to everybody else. But in the next one, I will create a protagonist index dictionary. So I'm going to recycle some of that rank proper nouns code right there that basically takes all the proper nouns and basically print out each protagonist and what their particular score, their index is. So this star tells me that this is processing. This takes a little bit of time. We have to basically parse the entire book. I should have saved the proper nouns in a separate file. Like, this is why I pre-saved a bunch of stuff. But there you go. Every proper noun has a protagonist score. See, some are positive, some are negative. The president is a little bit positive. Captain is a little bit positive. Spinet is a bit negative, and so on. So now we can actually print that. Oops. I reran it. I'm sorry. So we can print that in a bar graph. And again, we may have a problem because we may want to filter out something that's not really a protagonist, but there we go. Harry, positive. Ron, more positive. Hagrid's a sweetheart. Hermione, slightly negative. Sophie, any reasons why Hermione would be like, does she nag? She did nag a lot, didn't she?
She was, yeah. She was very goody two-shoes, saying to the rules, and didn't like Harry and Ron being reckless. So
yeah, so there you go. Hermione is a good person, but she nags a lot, and that's why she gets a negative score. Professor's a weird one because there's Professor Snape and Professor Dumbledore. Dumbledore is the superhero of the thing. He's always nice to people, and Snape is actually kind of the villain. But I'm be curious to see sort of Snape's individual journey. So we got Dudley, who bullies Harry Potter, obviously. Uncle Vernon, horrible. Malfoy is his top rival. Malfoy is just like the sort of set up to be a bad guy from the beginning. Yeah, Uncle Vernon. Vernon is bad. Poor Neville. Neville Longbottom, right? Just, Sophie, another check here.
What?
Neville Longbottom was the kid that's super accident prone, right?
yeah, the one who fell off his broom in the first flying lesson. Yeah.
Right. So you've got basically, you know, it's not necessarily picking out the true villain, but I suppose you could be, Neville is a little bit of an exception to this. Hermione, but it's pretty accurate for everybody else because Neville's like a good person that bad things happen to. He's not necessarily the devil. Professor Quirrell is like, is Quirrell consciously a bad guy or is he just kind of mind controlled by Voldemort?
I think he started off being a good guy and then like somehow, yeah, Voldemort like possessed him.
But yeah, Gryffindor, positive. Gryffindor is Harry Potter's house. And Quidditch is a very, we were wondering, yeah, like Quidditch is also positive. So there you go. That's, I find that graph tells us a lot about Harry Potter. So yeah. Now the next one here is probably my favorite. And I'll have to, I guess, explain it slowly. So the idea for this set of programs is that we take a character and then we map out the emotions associated with that character from start to finish of the book. So instead of Harry Potter having a score of 89, we're going to see chapter by chapter, just like the chapter sentiment went like that. We're going to see that for each individual character of our choice. And that could be interesting, right? So how are we going to do that? Well, I've tried a few things, and the annoying thing is for anybody but Harry, there are big chunks of text where they're doing nothing. So like it would just be blah, 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 and then lots of flat, and then blah, 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 lots of flat. So instead of decided to extract sentences that contain a particular character's name and then just cycle through those sentences. So like if we were to pick character sentences for Snape, let me just clear these cells, all output clear. So if we were to put this for Snape, then you'd get all the sentences that Snape is in, right? Now, it's not going to essentially read like a book because, you know, he might be in at the start of paragraph 1, in the middle of paragraph 3, but nonetheless, it will just kind of tell you his emotional journey through the book. So next up, we're going to have a function that puts out a dictionary, and that is the character journey function. So the idea here is that you slice the book into slices of that sample size that you want. So you might slice the book into 100 pieces. You're actually going to slice the sentences where the character is in, say into however many pieces you want. And then piece by piece, you just compare the emotions. So that's essentially how it works. And then this is where you write the dictionary. So you're going to have a counter, which is going to be counting the slices. And then you're going to have the polarity of the text within that slice. And I've also done this cumulatively, which means instead of just taking the polarity of the current slice, we'll just add all the previous slices. And so you'll see how a character eventually arrives at their hero or villain score. So let's run that. And let's just put the graphs in for Dumbledore, and then we'll do it for different people, right? So Dumbledore, we're going to get the character journey and the character journey cumulative. So first graph is going to show us.
Sanjay?
Yes.
Sorry to interrupt, just got a quick question.
Go ahead.
Someone's asking if you can summarize each chapter relating to the character.
Can you summarize each chapter?
Chapter 1, chapter 2, Hermione.
Yes. In fact, look, the summarization, the algorithms that are involved in summarization actually have to have a very, very high, have to be very highly sophisticated. So you can get modules that do that, but it would be like working with a black box. So the answer is yes, it's not a part of these tutorials. And the level of understanding of what's inside those algorithms takes months. So you'd have to break text into those POS tags, and the tags would be trees. And then there would be a machine learning algorithm that matches those. That is one of basically summarizers are something that the OpenAI Institute is working on. So you can look up OpenAI and on YouTube 2-minute papers. So look at OpenAI 2-minute papers summarizer. So that's fairly advanced, but it does exist. Okay, so that would be the journey of Dumbledore. You notice that is 0. Dumbledore is constantly positive. He's only got, about 1/3 or 1/4 of the way in. There's a negative moment with Dumbledore, but he's overwhelmingly positive. And in the second sort of cell, you're going to see his cumulative. Like, this is it. He's positive, and he just ends up being more and more and more positive. But let's try Snape, because remind me, Sophie, does Snape do anything good in the first book, or does he begin to do good stuff in the second? Like, I seem to remember him as a pure villain, but I'm not sure.
I mean, he's one of those villains who's technically a teacher there. So in the first book, he's just taking off points from Gryffindor and being really hard. And criticizing the Slytherin, but
okay. Well, there he is. He really has some positive moments, right? Like, that is 0. Snape starts off super negative, but he has positive moments. And let's see his sort of cumulative arc. Yeah, he does a lot of bad things, and then he basically sort of stays there. So yeah, Snape is, I would say he's bad at the start, but then he's sort of neutral. So he goes bad, 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 and then that stays pretty flat. That's the sort of cumulative one. And let's see, he goes up and down around 0. Let's see, Malfoy. Is like Malfoy consistently bad? Malfoy has some kind of redemptive moment in towards the end. Oh, okay. Yeah, I mean, he's overall. Let's see Malfoy's second part. Yeah. Malfoy's up and down. Malfoy's up and down. Interesting. He does have a negative overall score, but he's not, doesn't seem that bad. Let's see Hermione. Are there moments in the book where she's not annoying, where she's very nice? Ah, look at that. That's pretty interesting. So she comes through at the end. She's like, her score improves dramatically. So she has like 2 moments. And by the way, like if you think what number these slices are, we can actually go and find the sentences in the text. I mean, this would be about 7. So you could basically pick slice numbers. If counter double equals 7, or counter double equals to 8. So you can like print out these slices. Again, they're not necessarily meaningful text, but you can, when we run this for Hermione, come on, what's the problem here? You can isolate key text here. I think this meant to have a hashtag because it's a comment. So yeah, this is the text with Hermione that's got some negative elements. Breaking rules, wouldn't be allowed, block the fire, threatened dog. So there are some sort of negative words there. I'm not going to read through all of it, but like you can actually, reading from the graph, you can print the associated text and sort of isolate negative words. So look, that's about it for the presentation. I suppose now that we're a bit open-ended, we can look at some things.
Yeah, I mean, to be fair, I am like so Gryffindor, and Harry Potter is all about like Gryffindor, Gryffindor, Gryffindor. I want to see like how emotional each of the houses. So I feel like Ravenclaw would be very like logical, Hufflepuff would be very like positivity. So the room would be.
Yeah, that's a fun one. That's a fun one. Okay, so like, which one can we recycle? If we look at like chapter sentiment, hero or villain. So instead of hero or villain, remember how we got like Quidditch was popular? Like Gryffindor was actually there. But yeah, we could do all 4 houses. We can actually, yeah, we could print the protagonist score for all 4 houses. So, Sophie, you have to be my spell checker here, because Gryffindor.
Gryffindor. Oh, that's one I always get wrong. I think that's right.
In fact, oh, what's? Oh, yeah. I need to actually copy that because I want to print it in a nice printable way. So it's going to be Gryffindor. And then we're going to have Slytherin. All right. You'll know if the score is 0, we've misspelled it, right? So Hufflepuff, Hufflepuff, and Ravenclaw. All right, so we're going to need that and a space. So we're going to print these scores for all 4 houses. So we got Gryffindor, Slytherin, Hufflepuff, and Ravenclaw. Now, this will be interesting because these houses don't appear as often. We may like, see for Harry, I could do like, for major characters, I did paragraphs. We might have to do sentences, like if the scores are anomalous. All right, what's up? Invalid syntax, Slytherin. Okay, these guys need commas. That's a comma needed there, and a comma needed there, comma needed there. All right, let's try that again. Oh yeah. Slytherin has a positive score somehow. Hufflepuff, I don't know. That's strange. What if we used sentences instead of paragraphs? Because the reason why these scores could be wrong is because there's not going to be entire paragraphs that are about Gryffindor or Slytherin or any of them, right? So if we break it down into sentences, okay, that makes more sense. Gryffindor is sentence by sentence, super positive. Slytherin, the most negative. Hufflepuff, slightly negative. So they're nice.
It's really surprising.
Well, maybe like people take advantage of them, or maybe people badmouth them because they're nice, you know, like that would have to be it. But Ravenclaw does not surprise me. They're sort of standoffish and, you know, they do their thing. But yeah, Gryffindor is even more heroic sentence by sentence, funnily enough. So there you go. I could just mess around with this, right? And instead of, we could give them subjectivity scores instead of polarity. So if I go subjectivity, I should have really made a copy of this. In fact, I'm just going to do that now. New, make a copy. So in the copy, I'm going to turn this to subjectivity. And this is going to be telling us how objectively other people talk about houses. So it should still they should all be, they're all going to end up being positive because there's no negative scores. Or I don't even know how this is possible. Oh, Blob, you're multiplying polarity. If candidate in paragraph, let me just rewrite this whole function. Score plus equals to blob.subjectivity. So what I'm trying to do here, Sophie, is actually check the bias associated with each house. And I've basically rewritten this function completely. To calculate, there you go. J.K. Rowling, Harry Potter, Hermione, all of them are most emotional when talking about Gryffindor and Slytherin. They're much less emotional when talking about Hufflepuff and Ravenclaw. So you kind of know where the emotional tension is in the book, which actually, I mean, this to me is interesting. It actually means something, right? Because Hufflepuff and Ravenclaw in many ways are not involved in the main plots. It is Slytherin versus Gryffindor on Quidditch. It's Slytherin versus Gryffindor in the battle of good and evil. And that's where the emotional language is used, associated with really these two words.
Yeah, I feel like I can't remember the book exactly, but it's the Triwizard Tournament where the Hufflepuff, the captain, sadly, I don't want to give away like any spoilers, but he's from Hufflepuff, and he like has to
Give
go
away the spoilers.
Like, there would be like more emotional tension, obviously, with Hufflepuff. So.
Okay, so it's still more than that. Ravenclaw, non-surprisingly, have the lowest score, which means they're the closest to objective language of anybody. So there you have it. Okay, guys, from the audience, if you guys have any questions, now's the time to drop them in. There's a bunch of people watching on YouTube. You guys can also leave questions if you're interested. Otherwise, we're going to wrap this up. I'm just going to send you a link one more time in the chat, and I will show you the resource page from where, oops, Head Start Academy, no, come on. It's going to be in free resources, Python book analysis. So this is going to be an actual introduction with all of the TextBlob popular functions. This is a full Python course. These are advanced tutorials in NLTK. This is my free online course with book analysis with AI techniques that I talked about at the very beginning of the webinar. And this is a link to all of the programs which are available again for free in GitHub. The web page for this is going to be in the chat. It's also going to be, I'll put it in the YouTube comments. And yeah, if there are no, oh, Sophie, question, can we summarize each chapter? Yeah, we've answered that. And yeah, I'm gonna put that in the comments. Interesting, I've got the Q&A, but where is my just chat? Is there chat? Yes. To all panelists and attendees. Okay. That's everything. Sophie, thank you very much for coming.
No problem at all. Yeah, no problem.
And yeah, I hope everybody had fun. And I will follow up with all of the links to the resources via email and the recording, which is out on YouTube. So thank you very much. And yeah, see you at another webinar.